Now, an oscillator is an electronic component that vibrates at a certain rate that generally tracks with the keyboard. In other words, if I were to hit a key down here, it would vibrate at that speed, giving us that pitch. And as we went up, it would vibrate faster, giving us a higher pitch. Now, there's a second component to oscillators, which is the waveform. What shape is the waveform of the oscillator? And they have thrilling names such as sawtooth, square, and triangle wave. Let's take a closer look. You can see that the JPs have two oscillators, brilliantly called Oscillator 1 and Oscillator 2. I'm sure they were up all night dreaming up those names. Anyway, Oscillator 1 is the more powerful of the two, but to start our understanding, we should probably begin with just Oscillator 2. Before we play with Oscillator 2, we should isolate it so that we're only hearing just its output. You'll notice in the oscillator common section that we have a knob labeled Oscillator Balance. Twist it all the way to the right so we're hearing just Oscillator 2. Now we can concentrate in just those few controls that are in Oscillator 2 section, and we can listen to the differences between those three waveforms that do the oscillating. Here's the waveform. There's buzzing around the JP, and it can be either a square, sawtooth, or triangle wave. Now here's the differences in how they sound. Here's the square wave. The sawtooth is a bit more of a raspy sound, and the triangle wave is a bit more hollow, or kind of more of a reedy sound. Now you can tune this oscillator by using the two knobs marked range and fine. Both have detents at their 12 o'clock position, and the range knob tunes the oscillator up or down 2 octaves, or 24 semitones. The fine knob does double duty depending on whether the range knob is in these highlighted areas marked wide. If you're outside of these wide areas, in other words, anywhere plus or minus 24 semitones, then the fine knob will bring you up or down a half a semitone, or plus or minus 50 cents. If you go into the wide area, then this fine knob will go into changing you plus or minus 4 octaves. So basically all you have to tweak here in the Oscillator 2 section is the waveform, either the square, sawtooth, or triangle wave, and you can tune it from here using the range and the fine. The remaining two sliders here are only effective if you have selected the square wave as your waveform. You can see that the sawtooth and the triangle waveforms are fixed in that the oscillator vibrates in two fixed ways, either in a sawtooth way or a triangle way. You also notice that the square wave has a dotted line traced along its graphic. Now if we select the square wave here and move the two sliders all the way to the bottom, then what we're hearing is the sound of a standard square wave. If we move the pulse width higher, we move the waveform from being a square wave to being a pulse wave. We're actually changing the width of that pulse from this to this. And again, this is what it sounds like. Pulse wave, square wave. Now we can also modulate the pulse width by the pulse width modulation depth slider. This is kind of like you automatically moving the pulse width slider up and down, and it's actually reliant on LFO 1. But don't freak out yet, we'll get to LFOs a little bit later. Let's take just a bit at a time. So Oscillator 2 is pretty simple. You just select which waveform you want to use. You can tune it using the range and fine knobs, and if it's a square wave, you can modulate its width. Oscillator 1 though has a few more bells and whistles, and we can isolate it by going into Oscillator Common and moving the Oscillator Balance over to Oscillator 1. Let's take a closer look. Here you have 7 waveforms to choose from. You can see that the last 3 here are the same as Oscillator 2's. You'll also see that the first 6 of them have labels that show what each of these 2 sliders do. In other words, if we were to select Super Saw here, then this slider is detune and slider 2 is mix. If we were to select noise, this slider would be cutoff frequency and this slider would be resonance. Don't worry if you don't know what some of these mean, just do understand though that these two sliders will have different functions depending on what waveform you have selected. And we'll go through all of the waveforms, but before we do, let's just talk about the new super saw technology that are in both the 8000 and the 8080. To explain this, let me give you this example. Have you ever heard a solo violin? Now it's a really pure sound, but it's pretty thin. It's only really when you get a whole bunch of violins playing together that the sound begins to be fairly lush. Now the reason that it becomes lush is that each of those violins are slightly detuned, and they're detuned just enough to make it sound fat. Now with synthesizers it's the same thing. It's not a well-kept secret that the more oscillators you have, the fatter the sound is. Trouble is, it normally costs a boatload of money to make a synthesizer with a bunch of oscillators. But Roland has modeled the sound of 7 sawtooth waveforms oscillating at once. I don't know how they did it. Some deep math was probably involved, but it's a good thing. Now, let's take both of these sliders down to the minimum and we'll play the sound. Doesn't sound that big at the moment because we're basically hearing just one of those sawtooths. If we start cranking up the second slider and mix, we start adding more of the remaining 6 sawtooths. You'll notice that doesn't really make that much of a difference, in the same way that if we were to add 6 more violinists that happen to be perfectly in tune, that really wouldn't make much of a difference either. Now, I'm not talking about whether they happen to remember to tune up that day. Hopefully they're all in tune, but I'm talking about that subtle amount of detune that makes a single sound more of an ensemble sound, makes it fatter. The first control slider here is marked detune, and when you bring that slider up, that will slowly span out those oscillators and detune them slightly, and you'll get a fatter sound. Lush. Experiment with each of the waveforms and you'll be able to see what each of these 2 sliders do for each of these selections. To the left of oscillator 1 is oscillator common section. Now, we've already seen how we can mix between the 2 oscillators with the oscillator balance. Here's a breakdown of the rest of the knobs, buttons and sliders. Let's bring up template 2, which is UB88, and we'll turn off the effects. The ring and cross modulator allow interaction between the 2 oscillators that bring on a new set of overtones that are kind of metallic in nature. You can see that the more you cross modulate, the less fundamentals or pitch sounds you hear. The tone becomes less about pitch and more about complexity and overtones. Just to the right of these knobs we have a couple of sliders named A and D, standing for attack and decay. This is a basic envelope. And we probably should get into envelopes right now because they're going to be becoming far more prevalent when we get into the filter and the amp settings later on in this videotape. And it comes down to this: most sounds change over time. If we were to play a guitar, you can hear how it starts off with a pluck and then slowly dies away as those strings start slowing down and finally cease to vibrate at all. We can say that the volume or amplitude envelope consists of a fast attack and a slow decay. Now, if I was to mute some of those strings with my palm, sometimes you see guitarists kind of muting those strings. You know, it sounds like this. You can say that has a short attack and a short decay. If I was playing, say, a violin or a cello, we could say that the volume or amplitude envelope of that is a long attack and a long decay. In the same way, the A and D here, the attack and decay, give you the ability to change a characteristic of the sound over time. In our example of the guitar just a moment ago, we were modulating the amplitude over time, but there are other things that we can modulate or change over time as well. Here's an example of a slow attack modulating a volume. Here's an example of a slow attack on an envelope modulating the timbre or the tone of a sound. And finally, we can use a slow attack adjusting the pitch of a sound. So you can hear from these three examples, envelopes are really nothing more than things that modulate or change certain characteristics of sound over time. Let's do an experiment. We'll turn the balance all the way over to the right, so we're just hearing oscillator 2. We'll turn cross modulation depth off and make sure this knob's on at 12 o'clock. Just above you'll see a button that assigns the envelope amongst other things. Let's press it so that it gets to oscillator 2. Now this attack and decay, this envelope here, will affect the pitch of oscillator 2. Turn the knob marked envelope depth all the way to the right so we get maximum use out of this envelope here. Now we can play with the attack. You can see that the higher we take the attack slider, the longer the pitch takes to bend. You can play with a decay slider as well to decide how long it's going to take for that pitch bend to come back down again. Now the amount that we bend is governed by the envelope depth knob. You can see that the time that the bend takes doesn't change, only the width of the bend. And in fact, if you go to the left side of 12 o'clock, the bend will go the other way. So back to the destination button here, we can decide what will be affected when we hit this button. Oscillators 1 and 2's pitch, just oscillators 2 pitch, or the cross modulation depth. So you can see in the whole oscillator section here, these three sections here, we can choose what the waveforms will be for each of the two oscillators here, and we can control the interaction between the two in the oscillator common section. Now the next section of the JP8000 we're going to explore is the filter section, which restricts certain overtones that can be passed through. Now, a crude example of this is when you open and close your mouth when you sing. Ow, ow, ow. As you close your mouth, you start restricting some of the higher frequencies. Let's explore the filter section. The cutoff frequency in the filter section is like opening and closing your mouth. This is the edge of the filter, and depending on what type of filter we select, we have three types here, we can let certain frequencies pass and filter the rest. And we can hear frequencies from the very low to the very high, and when we slide this cutoff, we are moving the filter from the low frequencies, the bass, up to the high frequencies or the treble. Now if this is getting a little bit too abstract for you, let's look at an example, and we'll start out with the high pass filter at HPF here. If we move the cutoff all the way to the bottom, we are saying that we are passing all frequencies above this slider. That's why we say high pass. That would mean that we're basically passing everything. If we raise this filter, only those higher frequencies are going to survive. Everything below the slider are going to be weeded out until we have almost no sound at all when we reach the top of the slider. Now if we select low pass filter, we're around the other way. The slider kind of behaves like a limbo stick. Keep it high and everybody gets through, but start bringing it down and you end up with just the lower frequencies. Move it up and down, you get that analogy of opening and closing your mouth we did just a moment ago. The second type of filter is the band pass filter, which moves just a selected band of frequencies up and down.